Hi, in last videos we have seen about blockchain, what is blockchain and its evaluation and its characteristics, and about the chaining, hashing, and about the Merkle tree. Uh, in last video I have told you that we are going to see about mining and finalizing blocks. Before that, before we are going dive into mining and finalizing blocks, we are going to see about consensus in blockchain. Now let's go on to the topic and see what is mean consensus first. First, imagine that there are 10,000 strangers scattered across every time zone on Earth. Nobody is in charge. Nobody is there to take the charge for every activity. No CEO, no bank manager, no government official, and yet every single one of them agrees right now on exactly how many coins are in their wallet and exactly which transaction happened first. No meeting, no paperwork, no trust. How is that even possible? The answer is one word: consensus. And by the end of this video, you will understand exactly what that word means and why it's the single most important idea in all of the blockchain. Next, we are going to see about the definition of consensus. Let's see that. A consensus mechanism is the set of rules a blockchain network uses so that independent, mutually distrusting computers called nodes can agree one single valid version of the ledger without needing a central referee. Notice the two hard words: independent and mutually distrusting. Nodes do not know each other. Some might be honest, some broken, some actively malicious, trying to spend the same coin twice or rewrite history in their favor. Consensus is the protocol that makes all of that irrelevant. It guarantees that as long as the honest nodes are the majority, the network coverages on the truth every time. Now, let's see why this is hard. Let's borrow a classic thought experiment from computer science: the Byzantine generals problem. Gen- so, several generals surround an enemy city. They can only communicate by messenger, and they must all attack at the same time or all retreat, because attacking alone means defeat. The problem was some messengers might get lost, and worse, one or two generals might secretly be traitors, sending different messages to different peers to sabotage the plan. The question is, can the royal general still reach the same decision despite unreliable communication and active traitors? That's exactly the problem a blockchain faces. Replace generals with nodes and attack or retreat with which block is next, and you have the core challenge every consensus mechanism is built to solve. So let's see how we are going to solve this hard problem. Every consensus protocol, no matter how different it looks on the surface, is judged against three non-negotiable properties: safety. First one, safety. Honest nodes never disagree on the final confirmed history. Two conflicting blocks never both become permanent. Next one, liveness. The network keeps making progress. New valid transactions eventually get included. The system doesn't freeze. Third one, fault tolerance. The network survives even if Some nodes are offline, slow, or outright lying. This is the Byzantine fault tolerance we just talked about. Every design decision you will see in the next video. How much energy it burns, how fast it finalizes a block, how decentralized it can stay. Is really just a different trade-off between these three guarantees. Over the last 15 years, engineers have built dozens of consensus design, but almost all of them fall into three families. Compute intensive mechanism like proof of work, where nodes earn the right to add a block by burning computational effort. Capability or stake based mechanism like proof of stake, delegated proof of stake, and proof of authority, where the right to produce a block depends on what you have staked or who you are. Voting based mechanism like practical Byzantine fault tolerance, where a known set of participants literally vote round by round on the next block. So that's consensus. The invisible agreement engine that lets strangers trust a system instead of trusting each other. But which family should a blockchain actually use? Proof of work, proof of stake, or something else? That depends entirely on what you are optimizing for: security, speed, or decentralization. You genuinely can't max out all three at once. In next video, we will we will put proof of work, proof of stake, DPoS, PBFT, and proof of authority side by side and compare them head to head. See you there. Bye.